Okay, the recording is started. Thank you. So I'm now starting again. Okay. This is a Revit startup screen. Okay. Now, when you want to start a new project, you always start with a template. So I'll go to new. I'm using Revit 2026. You too, when you start a new project, you see a new project dialog box here, and you'll be required to select a template. Within the Revit 2028, there are two templates. One imperial, multidiscipline, and then one metric, multidiscipline. I'm going to use the metric to teach, so I'll choose the metric multidiscipline. If you are not using Revit 2026 and you're using a different version, look for metric, Revit anything metric, architectural metric or construction metric, and then you can use that one to start. Okay. You can choose browse also. When you browse, it will take you to the templates folder. There are so many of them: commercial, concept, construction, construction metric, default Great Britain, default metric. You can choose any of these ones. But because I'm teaching architecture, structures, mechanical, everything complete, you know, that is why I'm using the multi whatever. If you are sorry, I'm suffering from cough, so I'll be worrying you small. If you are doing only plumbing, you can choose a pipe template. If you are doing multi-system, say plumbing, electrical, whatever, you can choose system. If you are doing mechanical, you can choose mechanical. You understand? But I'm going to start with the default one, which is the metric default discipline. Okay. Then I'll choose OK. So it will start up a new file all together. Okay. It will come with some views, some legends, schedules and quantities, sheets, families, groups, and then links. To start from scratch, what I'm going to do is that I'm going to delete all the views, everything, and leave only 4 elevations. I'll delete everything. So I'll delete the structural drawings, I'll delete the plumbing, all the mechanical drawings, I'll delete them. I'm starting everything from scratch. So you too, if you are sitting behind your machine, you can follow suit. Delete all the views, all the floor plans. I only want to leave the elevations. Floor plans, delete everything. If you go to architectural, you see that there are sections here. I'll delete the section. There are building elevations here, east, north, west. I'll leave that one, and then delete everything. Now, if I open one of the elevations, I can delete the architectural. So in effect, I only have east architectural, north architectural, south architectural, west architectural. But for the purpose of teaching, let me delete the architectural from it so that it will be simplified. So I'll right click, rename, and then just leave it at what? East. Okay, enter. I'll right click the north also, rename, and make that one to north, just north. Later we'll recreate them. Rename this one also to south. Then rename this one also to west. So there are only elevational drawings that you can see. Okay. So
recording in progress.
So I'll take this one, rename this one to, I think, rename this one to west. So that you should be left with only the elevational views. Enter. Are you okay? Now, when I click on Views Discipline, I'll come to the project browser and then change it to all. So at least you can see all the elevations here. So there's nothing in the view apart from the what? Elevations. Are you okay? Hello?
I'm not okay. I missed the part where you moved to the project browser.
When you come to the project browser and you click on the views, if you click on the views, you see that mine, it is showing all, views into bracket all.
Okay.
If it's not showing all, click on the views, go to the project palette, and you see browser views, all, discipline, not on sheets, face, type and discipline, then choose the all.
Okay.
So that you see views into bracket all. And then delete all views and leave only the elevation views.
All right.
Yes.
Thank you.
Delete every view and leave only the elevation views. So there's no other view apart from four elevations. Are you on the same page now?
Yes, sir. Thank you.
Okay. Now, you can click on the 3D view here at the top here and then open it. So there are so many things in the view. Understand? So I'll delete everything. Select everything and delete. The levels, delete all of them and leave just one level. Because you cannot delete all the levels. It will not give you the opportunity to delete it. So if you delete it, will just be left with just one level. So that we have 4 elevations and then one level. If you go to the one of the elevation views, you should see only one level here, called level 1. Please give me a minute. Hello. Hello.
I said.
Yes. Sorry for the interruption. I said
It's okay.
delete everything from the view and leave only 4 elevation views there. Okay. Now anything else, delete anything else you see on any screen. So you only see only one level in any of the elevation views. Anything else is insignificant. Okay. So if I open elevation view east, I'll see one level. If I open the north, I'll see one level. If I open the south also, I'll see one level. And then the east also, I'll just see one level. So we are all on the same page.
Yes, please.
Are you okay?
Yes, sir.
Okay.
Yes, sir.
Good. Now, as we discussed yesterday, when you are doing with Revit, there are 3 things that should concern you as a Revit user. Categorically, there are 3 things. The first one, we call them datum elements. Datum elements, made up of levels, grids, and then reference lines or reference planes. Then we have another set called content. The content is either 2D content or 3D what? Content. And then the third thing is the views and then the what? Sheets for representation. So you need the datum elements to be in place before they can be what? Content. Without datum elements, there cannot be content. Do you understand? And without content too, there wouldn't be the need for views and then for what? For sheets. So in the first place, we must understand how we work with the datum elements first. And the datum elements we're looking at first is the level. And if you look at the level, like I said yesterday, if you look at geometry, any geometry is basically, fundamentally, if you look at geometry, we have a point, which is a single point that you can place. When you have 2 points, it gives you what? A line. When you have more than 2 points, it gives you a polyline, which can be an open polyline or a closed what? Polyline, which is a polygon. You understand? Now, when it comes to a level, it's just a line, a straight line, nothing else. So if I select this line, it's a line. It doesn't necessarily have to have a length. It's just representational. So I can stretch it and make it shorter. I can stretch it and make it longer. It doesn't bring any difference. It is still what? A level. So my level can be this short. In Revit, it can still work. It doesn't mean anything. It is very representational. So this is just a level. Are we okay? Are we okay?
Yes, sir. Yes, sir.
Now, look at the level very well. At the extreme end here is a symbol for the level. We call it the level head symbol. The level symbol, head symbol. You can switch it off, or you can switch it what? On. If you come to the left also, you can switch it off with this checker box, or you can switch it what? On or off. So you can either show the levels head, or you can decide not to what? Show it. So it's just basically what? A line. Okay. Now, if you take this level, you can show this symbol. This symbol here is made up of the level head symbol, the name of the level, and then the elevation of the what? Of the level. You can customize it. This symbol here is just a 2D line work that we've done. Later we will look at it. Basically, this is the datum symbol. This is not a level symbol. So if you see anybody who is using Revit and is still using this datum symbol in his project work, then it means there's something wrong with the person, or there's something wrong with the project that the person is working on. You need to be able to customize this level head to meet proper architectural standard. Nico? Sir Nicholas?
I'm listening.
Please, on this level head, is this circular head, is it acceptable level? As in terms of level symbol. Hello, Nico.
I'm listening.
I said this level head, is it acceptable as a drafting standard that you can use as a level head? Can you hear me? Hello? Hello? Can somebody help us?
Hello.
Yes, sir, Nico. Nicholas. Can you hear me?
Hello.
Yes, sir. Can you hear me? Hello.
Can you hear me now?
Yes, I can hear you.
Okay.
I'm asking if this level head is an acceptable standard for drafting for a level. You can unmute your camera and then talk. Fire. Actor Fire.
Hello, my
Fire.
guy.
Yes, sir.
Hello.
Yes, sir.
Yeah, good evening. I can hear you.
Yes, I'm asking if this level head symbol that you see on my screen here is it an acceptable standard for architectural drawings?
As in level, no.
So this default level head that is here, we call it a datum symbol. This one you see here is a datum symbol. It's not a level head, but you can customize it. So I can take the level and then switch it off or switch it on. But if you want to design a proper level head, I don't think this is a proper level head. So we should look out for the appropriate design of a level head so, so that we can implement same. Okay. This one you can always redesign, so you look at it. But that one is a topic for another day, not for today. But what is important is that this level, I can create more of them. Okay? I can select it, choose copy here, and then make a copy. When I make a copy, I have 2 copies. Please, sorry. I'm not feeling well, but let's manage. I have 2 copies of the levels. You can name each level the way you want it. So I can click on this one and then call it ground level. Okay. I can click on this one and then call it first floor level. I can create another level by also copying it again. And I can decide to call it level 4, L4, or I can call it 003 as the level name. Whatever name I give to the level, whatever name I give to the level is at my own discretion. If you are working alone, you can give the level any name you want. It's a level. It's not a floor plan. It's a level. So if you want to call it a basement level, mezzanine floor level, 3rd floor level, level 1, L1, L2. So let me copy this one, for instance, again, CO again, and then copy it. Then I can decide to call this one L1. Let me make it capital, L1. So this is also another name for the level. But ideally, when you are naming your levels, you should be very, very, very consistent in the naming of the levels, so that even if it is your own drawing, or even if the person is a team member in your team, and then the person look at your levels, by the naming you give to the levels, the person should understand what the levels would mean. Are you okay? Are you okay?
Yes, sir.
Uh-huh.
please.
So for me, I'm going to use L1, L2, L3 for my level naming convention. Okay, so the level, ground level, I'll call it L0 for ground level. Then for the next level ahead of it, I can call it what? L1 for level 1. You see that another level is already named level 1. So you cannot name this level here also as level 1. Each level must have a unique identifiable name to it. So what I'll do is that I'll cancel, then I'll change this one to L2 level 2. I'll change this one to level 3, L3. So I have L0, L1, L2, L3. But you must arrange them in a manner that the organization will make sense. So I'll take this level 1, move it down below level 2 here. You understand? So I have level 0, level 1, level 2, and then level what? Level 3, which are different levels. So basically, these are levels. And to create levels, you can go to architecture menu, go to datum here on the stream right here. When you go to datum, you should see level and grade. When I click on level, I can easily draw another level from here and then draw another level all the way to the end here. So this one will give me another level created. So when I select the level, you realize that there's a checkbox here. If I check it, it doesn't show any level. If I come in here, it's also checked. It doesn't show any level. But if you look at it critically, don't be confused. You realize that this line pattern here and then this line pattern here, there are two different lines. So what might be the reason for this? If you select the level and go to the properties, it says that it is a level, no head. But if I come to this one and I select it, it says it is a level 8 mm head. So these 4 levels here, all of them are the type 8 mm head. If you select this one here, it is level no head. So that if I select all of them, 1, 2, 3, 4, 5, all of them belongs to the category levels. But if you come to the types, it is telling us that multiple types are what? Selected. So you can always go to the drop down and then choose between either 8 mm head or arch 8 mm symbol ends or no head at all. So always don't get confused. But for now, let me choose the 8 mm head level. So you see all the levels here as you can see them. Okay. If you select each level, you can check the symbol on or you can check the symbol off. If I want my level heads to be represented on the left, I can select this one, uncheck, and then check here. Select this one, uncheck this one, then check here. Select that one, uncheck this one, then check here. Select this one to check here, uncheck this one, then select this one to check here, and then uncheck this one. So I see that right now, all the levels are on the what? On the right. And then these levels here, they don't show anything. Any question?
Okay.
Yes, sir. Who is talking? Hello? Please, who is talking? If you want to talk, you can unmute it and then talk. Hello.
I think we are okay.
Yeah,
I think we are okay.
everybody's okay. Okay,
Yeah, we can
good.
proceed.
Yes, sir, we are okay.
Okay.
Yeah,
Now,
yeah.
what is important is that when you have a level, then it means you can create a floor plan out of it. It can be a floor plan. It can be a reflected ceiling plan. It can be a structural plan. It can be any form of plan you want to work with. So long as it shows a horizontal section between a building, then it means that you can create it from what? A level. Without a level, you cannot get a floor plan. You cannot get a reflected ceiling plan. You cannot get anything. So when you create, that's why I deliberately deleted all the floor plans from here. So if I want to generate floor plans from these levels, what I'll do is that I'll go to the view menu on the menu items, go to the create panel. Then from the create panel, you should see plan views here. Create a 2D plan view such as structural plan, floor plan, reflected ceiling plan, plan region or area plan. So when you click on the drop down, you can create a floor plan, a reflected ceiling plan, a structural plan, area plan, anyone you want to create. So for now, I can choose what? Floor plan. And when I choose the floor plan, I will see all the levels that I have created in my what? In my project. And I can decide that I want to create a floor plan for level 1. So I'll select the level 1, then I'll go to OK. As soon as I click OK, Revit will generate a floor plan here for me in the views called level 1, as you can see here. Please, a level is totally different from a floor plan. You cannot call a floor plan L1 because the floor plan is not a level. So when you create a floor plan, you must rename it to represent a floor plan. It is not a level. Don't confuse a level with a floor plan. You can generate a reflected ceiling plan from a level. Reflected ceiling plan is different from a floor plan. You can create a structural plan also. So you can also create another structural plan. So if I come in here, I can go to plan view, create reflected ceiling plan. Then I'll choose level 1. The same level 1, I'll go to OK. So you see that I'll get a reflected ceiling plan called level 1. Then I can come in again, floor plan, structural plan, based upon level 1. Then I'll go to OK. Then I'll get a structural plan based upon level 1. When you create the plan, you must name the plan to represent the proper plan name. So I can call it, I can rename it, and then call it level 1 floor plan. Do you understand? Are you okay?
Yes, sir.
Okay. So I can rename it and then call it, let me just call it level 1 floor plan. L1 floor plan. As we move ahead, we adopt appropriate naming conventions. Would you like to rename the corresponding level and views? No. I don't want to rename the level. It is only it is only the view that I want to what? Rename. So even if when I go back to the elevation south, the L1 will still remain what? L1. And you realize that because I have created a floor plan, the symbol color changes to color what? Color blue. When the symbol plan is color blue, it means that there is a floor plan associated with the level. When the color is black, then it means that there is no floor plan associated with the what? With the level. So I've created a level all right, but there is no floor plan. So as soon as I create a floor plan out of the level 0, then it will change to color what? Color blue. Are you okay?
Yes, sir.
Okay.
Yes, sir.
Okay, thank you very much. So that's the whole idea. So if you are a structural engineer and you are working, then it means that you can create a structural what? plan. If you're an architect and then you are working, then it means that you can create a what? Floor plan or reflected ceiling plan. If you want to calculate areas, then you can create an area what? Area plan. So when I choose area plan, for instance, then I can also create a level, let's say level 2 area plan. Then I'll go to what? Okay. Automatically create, no, I don't want to do that. Then you see that another set of views created called area what? area plan. Area plan for level 2. So if I go to the elevation now and I open it, you see that the level 2 is also showing blue, which means that there's an area plan or a floor plan or a structural plan or a reflected ceiling plan associated with it. Okay? Are you okay?
Yes, sir.
So let me delete everything and delete all the levels again and start again. When I delete all the levels, all the views, floor plans associated with the levels will also be what? Deleted. You will see them. But if you delete the view, the level will still what? Remain. Which means that every view is dependent upon the what? Upon the level. All plan views is dependent upon the levels. So now what I'm going to do is that I'm going to name the levels the way I want them. I normally want to give them a descriptive name that anybody will understand. So instead of calling it S0, I'll call this one at elevation 0 ground level. So which is that this level has an elevation 0, and that is supposed to be the ground what? Ground level. So I can check here and then uncheck here. So I only see the name at this point here. This ground level, I can use it to generate site plan. I can use it to generate block plan, block layout, all forms of layout that I want to generate related to ground level. I can generate them from this level here. Now the next thing that I need to do is that I need to create another level to do my work. So apart from the ground level, I need the ground floor level for my project. So to create a new level, I'll go to architecture menu, go to datum here, and click on level. When you click on the level, there are two options. You can draw a line. You see, when you hover the mouse over it, you can draw a line by picking what? 2 points on the screen. Or you can pick a line. When you pick a line, you use an existing reference line as a reference. Then you pick that line to create a new level. So when I choose draw a line here, I can come here and then pick a line here. Now you see when I move the cursor to the left of the line, you see there's a boundary line here, some dotted lines. Always make sure you see that dotted line. When you do that, then the level will automatically lock up with the existing level. Then I can draw another line to the end and make sure that it is also, there's this also boundary line here. Then I click here so that this lock will automatically lock it. If I don't do that, then I start from the middle here, say somewhere here, and then go here. It means that this line here will not have any relationship between this and that. So if I select these two lines and I drag them so that they move together, this one doesn't move along. If I want it to be aligned, I need to hold the end point here and then drag it to the end here to see the boundary line. Then they will lock together. So when I move them, they move together. Now, watch closely. This line here and this line here are not the same representationally. If you select this one is 8 mm head. If I select this one, it's level no head. So I will make sure that all of them are the same. So I'll choose 8 mm head for all of them. So that if you come in, you see that it's now showing. So I'll drag this one to the point here and align it. Then uncheck this one, then come to the left. This one is checked, then this one too is what? Is checked. So that I have my what? 3 levels, as you can see. These 3 levels, I can rename them the way I want them. So I want this one to be called ground floor level. Ground floor level. I'll call this one first floor level. First floor level. Okay, so I have ground floor level, first floor level, and then ground level. I can create another level also below the ground floor level for foundation. If my project is a multi-story building, then I need basement. Then it means that I can create more levels below the what? Ground floor level. The internet is unstable today because of the rains. So I'll go in again, choose level again. This time around, instead of choosing draw, I can choose pick. When I choose pick, I can easily pick a level. But if you pick it, it will fall on it. So you have to give it an offset. So I'll give it an offset of say 1200. And when I give an offset of 1200 and I hover over it, you see that it will drop 1002 below it or above it. So you should check where you want it to be. But I want it below.
Recording in progress.
So minimize. So I'll come in here, choose the pick option 1002, hover over it. So it will come down here so that it will create another level for me. And if you realize that anytime I create a new level, it is bringing me this same level here. The no head level, as you can see. No level head. So as soon as I choose to create a level, and I go to level, I should make sure that I select the level I want to work with before I even create it. So this time I'll choose 8 mm. Before I'll choose again pick. Then I'll give it an offset of say 1200 again. Then when I hover down here, then I'll get that same level here. So if I check here, it's checked, but it's no head, so nothing will show. If I select this one, then check here, then the symbol of what will show. So I'll delete this one. And I'll call this L8 foundation level.
Please, you can't see your interface.
You can't see my interface? Wow.
Yes.
Yes, please.
I'm coming. Maybe the internet is distracting.
Yeah.
Give me a minute. What's my meetings? Hold on for me. Maybe there was a distraction in the internet. Zoom. Can you see it now? Please, can you see it now? Can you see my screen now? Hello? Down on our internet, Charlie. Can you see it now? Hello?
Recording in progress.
Can you see my screen now?
It's loading. Yes.
You cannot see it.
Yes.
Okay. Okay. So now if you see the levels now, you see you now have about 1, 2, 3, 4 levels on the screen. You cannot see it clearly.
Yes.
Okay. So you now have 4 levels on the screen. I can name each level properly. Please name it in a manner that you can always appreciate it, or if somebody should pick it, the person can appreciate what you are trying to do. Okay. So I'll rename this one to foundation level instead of just foundation. Now, creating the levels is one thing, and then making sure each level is at the appropriate elevation is also another thing. Now my ground level is 0 elevation. My foundation level is negative 2004 here. And then the distance between my ground level and my foundation level is 1002. So I can use this value, we call it listening dimension, and then type the distance between my ground level and my foundation level. In this case, I want it to be 1200. Then I'll enter. So that I have this one. Now, if I check the ground floor and the ground level too, I'll just select the ground floor and make sure that the distance between the ground floor and the ground level is 3150 for my floor to floor height. And then this one is supposed to be about, let's say, 600 or 900 above the ground level. And then this one will be 3000. The first will be 3150 from the ground floor. So if I want to add a second floor level, I can add. But because this is a small project I'll be working on, I'll just add a roof level to it. So I'll go to level again. This time I'll choose pick. Then specify offset of 3150. Then click here. So a new level is now created. So I come here and check. Then uncheck this one. And then I'll rename this level here. And I'll call it roof level. So now I have 1, 2, 3, 4, 5 levels created. Foundation level, ground level, ground floor level, first floor level, and then roof level. Any question? You can unmute your mic and then ask a question.
I just joined. I want to recap if you don't mind, sir.
You said, what did you say?
I said I just joined. I just came. I wanted to just ask for a recap.
You have 45 minutes.
If there's an opportunity
this is not an
for that
excuse.
one.
I'll make the recording available to you so that you watch it. So just follow. We've not gone far. Okay.
Oh, okay.
We agreed to meet at 8 o'clock. We are coming 48 minutes late. It's not respectful, please. So if you look at the levels, we have 1, 2, 3, 4, 5 levels created. Now with the levels created, you can create a floor plan from it. Currently, there are no floor plans. So if I want to create a floor plan, then
I ask a question.
Okay, ask.
Yeah, I could see 3D and 2D close to the head of the level. Could you please elaborate on that one?
Yeah. When we are working,
Yeah.
the model that we are doing is 3-dimensional model. And then from the three-dimensional model, we can create 2D views also. So when you come in here and you see this 3D, if you click on the 3D, you see I can change to 2D.
Okay.
If you click on the 2D also, it changes to what? 3D. Now when you click on the 2D, then you see that the knob here change to a small dot. But if you click on the 2D again, then changes to a 3D, the knob changes to a what? A circular object here. Do you observe it?
Okay.
Watch.
Yes.
3D becomes a dot. 3D is a circular. 2D is a dot. When it is 2D, it means that when you are moving this level here, it is only reflected in this 2D and no other view.
Okay.
But the 3D extent for the level is at where this circular point what is. So within this south elevation here, the level head is at this point. But if you go to any other elevation, the level head will be at where the 3D what is.
Okay.
As you go ahead, you exploit better. So let me bring it back to where the 3D is, so they all be in line. Are you okay?
Okay.
Thank you, sir.
Yes, I'm okay.
And you're okay. Good.
Thank you.
You're welcome. Now that you have the levels created, you can decide to create a floor plan out of it. So I can create a foundation plan. The foundation, I don't need a reflected ceiling plan. And the foundation too, I don't need a normal architectural plan. I need a what? Structural what? Plan. So when I'm creating the foundation, I'll go to the view, then I'll go to the plan views, okay? Go to the plan views here, and then choose structural what? Plan. And when I choose structural plan, they choose that I can create a foundation plan out of this one. So I'll choose structural plan. Then for the structural plan, I want it to be associated with the level, foundation what? Level. So if I go to OK, watch the side there, a new structural plan is created called foundation what? Level, as you can see. Are you okay? Now if I go to the south elevation again, you see that the foundation now is turned to color what? Blue, which means that there's a floor plan associated with it, which is what? Foundation level. For the remaining levels, ground floor, ground level, first floor, and then the roof level, I can create floor plans for them. So I'll go to plan views again, then choose what? Floor plan. Now I can select first floor, use control, ground floor, roof level, and then ground level. If you click control, you can select or deselect. Okay? You can deselect or select using control which ones you want. So I want to select the ground level, roof level, ground floor, and then first floor level. When I go to OK, it will create all the floor plans for me. Ground floor level, first floor level, ground level, and the roof level. The names are arranged in alphabetical order. It's alphabetical order. It's not by force that it should start from the foundation or the ground level, unless you rename them in a manner that will be arranged the way you want. So you can bring some numbers in front or some characters in front just to arrange them the way you want them. But that one is another topic for another day. So this is what we have now. Any question? If you have a question, you can unmute and then ask. Hello.
Sir, please, we are good.
Everybody's good.
Yeah.
No question.
No.
Okay. Now if you go to the 3D view,
No.
you see all the levels in 3D. I think from 2022 and above, that is where you see the levels in 3D. In 2021 and below, you don't see the levels in 3D. Are you okay? We are good.
Yes, please.
Now with the levels created, you can create any building components, being it architectural, structural, mechanical, electrical, or what? Plumbing. So let's see how we can create them. So let's start with architectural first. And let's start with the major architectural element, which is wall. I can draw the wall in 3D. I can draw it in 2D. Or I can draw it in 3D, whichever way I want. Personally, when I'm modeling, I model most of the time in 3D. But because I'm teaching, I'll start with the floor plan, then we look at 3D. If you take a wall, for instance, a wall is a linear element, it's a line. Then we draw by 2 points. Okay? So anytime we are drawing a wall, it can either be, I'll just pick a wall, I'll come back to the details later on. It can either be a straight line, or it can be a curve. A curve. Nothing more. Either the wall is a straight line wall or it is a curved wall. If it's a straight line, you must know where the wall is starting from. Then you must also know where the wall is what? Ending. That is, you should be able to define the length of your wall. It can be 3 meters, 3,000 mm. It can be 6,000 mm. Or it can be any distance. If it is a curved, you can specify the radius of the curve to be 6,000, or the radius can be 3,000, or the radius can be 12,000. You can specify where it is starting, and you can specify where it is what? Ending. You must know where the curve, you want the origin of the curve to be. You have to specify. So normally you have a reference point that you pick from. So for instance, I'll draw a line first, and then when I want to draw a curve, a wall here, and I choose a curve, I can say I want to start from the end point here, come down maybe 3.6 meters here, then before I'll draw my curve. So I'll get my radius of what? 1,800 mm. So you should know where your curve is starting, where the curve is ending, and then the radius. So basically, these are the two things you need to create any building complex. So if I take this wall here, and I create 4 of them, create similar. Start from here, come to the end here, go here, come here. It is 4 walls that I have drawn to get this room defined. So I can add more walls to create more spaces depending upon the design requirements. I can take this wall, delete it, take this wall, extend it to come and meet this one, take this wall, extend it to come and get this one to create this shape. It's a matter of line work, then drawing the kind of shape you want to be on plan. So that's how you draw walls on plan before I look at it in the elevation. Any question? Are you okay?
Yes, sir.
Yes, sir.
You are good. Now let's look at the next thing. A wall has a height. If I go to 3D, the wall has already been drawn with a height already. So the 4 walls that I drew, these are the 4 of them. When you select each wall and go to the properties here, let me minimize all the categories here and leave only the constraints. You realize that there is a base constraint for the wall. Then there is a top constraint also for the wall. The base constraint is ground floor level because that is where I drew it. the top constraint says that it is unconnected, and then the unconnected height is what? 6,000. So I can change the unconnected height to 3,000, and then the wall height will be adjusted to 3,000. I can change it to 600. Then the wall height will be what? 600. I can change it to 12,000. Then the wall height will be what? 12,000. But because we are doing a parametric modeling, it is not advisable to assign absolute values to walls, as in the wall height 3,000 or the wall height 4,000. It is always advisable to constrain the wall to what? To levels. So when I select this wall, I can say that the base constraint is ground floor level. And then the top constraint, I don't want it unconnected, but I want it to be associated with a different level. You understand? And because we are talking of the top constraint, which means that the level should be above the what? Ground floor level. Because the base constraint is ground floor, the top constraint cannot be the foundation level, but it can be any level above the ground floor. So either the first floor or the what? The roof level, but it cannot be the ground level. So if I choose the first floor now, the wall will be constrained to the first floor. If I select this one, and I say I want the top to be constrained to the roof level, then this one will be constrained to the roof level. So realize that this wall here is constrained to the first floor level. This wall here is constrained to the what? Roof level. I can select all of them at once. Watch something. When I select all of them, their base constraint, all of them is ground floor level. But the top constraint, it is telling you that it is what? Varying. Which means that all of them, their top constraints are what? Different. But because I've selected all of them together, I can change all of them simultaneously to the level that I want it to be. So if I change it to roof level, then all of them will be constrained to the what? Roof level. What that means is that when I select the roof level and I change the elevation of the roof level to say 21,000, and then I enter, because all the walls are constrained to the roof level, anytime the roof level changes, all the walls will change with respect to the what? To the level. If you are doing AutoCAD line work and you are doing a multi-story structure, then you have different line work for elevations. 4 elevations, let's say 4 sections, and there will be the need for you to change one of the levels. Then it means that you have to manually edit all the 4 elevations separately, edit all the 4 sections separately. So the person will complain that I've worked the whole day, meanwhile the person just wasted the whole day. But if you constrain your walls properly, as soon as you update the levels, all the walls will what? Update. So if I select this one and then change it back to 3150, all the walls will update to reflect. Any question? Hello? Is everybody okay?
Yes, we can proceed.
Yes, sir.
You can proceed.
Yes, sir.
Now, if I take this wall also, I can change the base constraint from the ground floor to first floor. You see that I've selected only one wall, so only the ground floor of this wall will change to this. I can select this level separately, individually, change the top constraint of this one to the first floor, then to update. So you as a designer, you as a modeler, having created the levels for your projects, at any point in time, any wall that you create, you must know from which level is the wall starting and to which level is the wall what extending to. For instance, if you're doing a multi-story building and they say there's a lift well or a lift shaft, you must know where the lift shaft is starting from, and then you must know where it is ending so that you construct it appropriately. Are you okay? So now select all of them. Let them start at level 0, which is ground floor, and all of them will end on what? First floor. Any question? No question. Now let's look at, let's say, services. Plumbing. So I'll go to systems, for instance, then go to plumbing, pipes. So I'll look for system HVAC, fabrication, MEP detailing, mechanical piping, plumbing and piping. If I choose a pipe and I'm drawing a pipe, so I'll click on pipe here. And the pipe too, I must know the level. Sorry. The level on which I want to draw the pipe. So if I want to draw the pipe on first floor, I'll choose first floor, which means that when I draw a pipe, this pipe that I've drawn 9,000 meters, this is a pipe. And this pipe is drawn on the level, if I select it, it tells me that it's on the level what? First floor level. And it has the middle elevation here. Every pipe, apart from the level on which the pipe is, you must also define the elevation of the what? Of the pipe. Let me go to the, maybe the south elevation, and so that you can see. So this is the same pipe in elevation. When I select it, this pipe is about 2,743.2 above the what? First floor level. So if I change the elevation to 600 and then enter, then it means that the pipe will be what? 600 above the what? The level. I can check the dimension, DI, from here to here. So you see that the pipe is what? 600 above the level. So when you are drawing a pipe, when you are drawing a duct, when you are drawing cables, all of them, they are linear elements, and all of them are associated with what? A level. So when anytime you are drawing it, it can be above the level or below the what? The level. So when I say that it is negative 600, then it means that it will fall below the level by by negative what? 600. The detail Charlie, I'm in trouble. The detail level is at coarse. If I change the detail level to fine, you see the proper pipe, as you can see. So if I go to 3D now, and I change the detail level here to fine, I'll see the pipe in 3D. So this is a pipe. And this pipe, as you can see, it is at elevation of negative 600 relative to the level what? First floor level. Any question? Any question? You can unmute it and ask a question. Charlie, this thickness. Hello. Hello.
Okay.
You are okay?
Yeah.
If you are not okay, you can ask a question. You are okay? Just like a pipe.
Okay.
I can also draw a duct, a mechanical duct for ventilation and air conditioning. A duct also have the same behavior, just like a pipe. When I draw a duct, also, this is also a duct. when I select this duct also can be assigned a level. So it can be on the first floor level. Let me go to elevation south. So this duct here can be on the first floor level, or it can be on the roof level, or it can be on the first or on the ground floor level. Anytime you assign the level, you must look for the elevation. Middle elevation, we have upper and top elevation, lower and bottom top elevation, then we have middle elevation. We'll discuss the details later on. But for now, let us focus on the middle elevation. So if I make the middle elevation 0, what it means is that this level, the middle will be on the level, groundwork level. If I change it to the first floor, then the middle will be on the first floor. But this time around, the elevation is negative what? 4,050. If I change the elevation to 0, then it will be exactly on this level here. So if you put any pipe or any duct or any cable tray, then you draw it horizontally. If you draw it horizontally, you must make sure that the pipe or the duct or the cable tray is assigned the appropriate level, and then the appropriate elevation is what? Defined. In this case, the middle what? Elevation. We will look at the upper top and this one later on, but let's focus on the middle elevation now. Are you okay?
Yes, sir.
Okay. Now, let me go to 3D again. Drawing pipes in Revit is very interesting. If I take this pipe, create similar, and I click here, it will draw it on that particular elevation. As soon as I turn here, it will put the appropriate fitting there for me. If I click in the middle here, and then draw in this direction here, Revit will put the appropriate fitting here for me. Now, as I'm drawing, the elevation, the middle elevation is negative 600 relative to the first floor. I can change the elevation to 1002 here relative to the same first floor here. If I click here, Revit automatically bring it above the 1002, and I can draw my pipe straight away this way and then add the connections for me, as you can see. So if I orbit it, you see that this pipe is now drawn in a 3D form. You understand? I can take it and then draw it again, create similar, and then turn to the left this way. Then the pipe is drawn. What I am saying is that when you are drawing the pipe, anytime you click, before you click the first point for building services, you must confirm the elevation of the pipe before you draw it. So let me delete this whole thing and then start afresh again. So I'll pick a pipe again. First thing, on which level am I drawing my pipe? Is the pipe associated with the first floor, foundation level, ground floor, ground level, or am I drawing it on the roof floor? For now, let me draw it on the ground floor. Then the size of the pipe, the diameter of the pipe that I want to draw. So let me do 150 pipe size. Then the elevation of the pipe that I want to draw, let me put it 0. So which means that the pipe is being drawn on the ground floor. It has a diameter of what? 150. Then it has a middle elevation of what? 0. So if I click a first point here and then draw, let's say 3009. It gives me a pipe of length 3009. I can branch 90 degrees, I can branch 65 degrees, I can branch 45 degrees, and then draw my pipe. So this is 45 degrees. Then Revit will automatically add a bend. Then I can continue in this direction and then draw a pipe. If I want to rise to a higher elevation, you have to input the middle elevation without cancelling, and then type say 3000. I want the pipe to rise by 3000. Then the pipe will automatically rise by what? 3000. Then I can move here in this direction 3000. If I want to fall down by say negative by 1005, then the pipe will drop by 1005. Then I can turn it and then draw it in that direction here by 90 degrees. So you see that I can draw my pipe in a 3D space as it is here, as you can see. Are you okay? The same thing is applicable to cable trays in electrical. So if you go to electrical cable trays or conduit, or if I want to draw electrical conduit and I pick conduit, the same concept. I want it on the ground floor. I choose the diameter for my conduit. This sizing, we look at them, how to size them properly. So let me choose any size. Then I choose the elevation that I want. For now, let me leave it at elevation 0. Enter. So I'll start on the ground floor. As soon as I draw, this is a conduit. I can turn here and then draw my conduit, go here, and then draw another conduit in this direction. And then if I want to rise, then I'll increase the elevation to say 315. And then draw my pipe there to rise, then I can draw my conduit there to bend this way. So you see that this is the conduit as I've drawn it. I can do the same thing for cable tray. Cable tray also behave the same way. The level, the width, the height, the elevation. So if I draw this one.
I'm trying.
Yes, madam.
Please, I have a question.
Do.
You are currently working in 3D view.
Yes.
In regards to the pipes and then the all the things you are drawing currently, if you are working, for example, in plan view, and you want to change the levels, for example, you started drawing on the ground level, and now you want to send the pipe up to the second level, are you still going to maintain, like, is this supposed to be still active before you change the level, or you can cut it, change your levels, then you continue your drawing?
Okay, let me go to ground floor level. You see that the pipes are here. So I'll choose a pipe again. This is a pipe. Now it's not displaying because of the view range sort of things. Let me change the elevation to 0 and see. It's not displaying. Okay, good. So now if I draw here, this pipe here, let me make it shorter. Currently, this pipe is at elevation what? 0. You understand? This pipe is at elevation 0.
Yes.
If I want to create similar, it's still at elevation 0. If I continue from here, it will still be elevation what? 0. If I click in the middle here, the elevation will still be what? 0. And it will add the fittings right away. But as soon as I change the elevation here to say 600, which means that the elevation is no more 600. It's no more what? 0. That is what? 600. So when I click at this point here, the pipe will start an elevation of what? 600. And Revit will automatically add the vertical member to it. So if I click here and then drag it this way, you see that it's a risen pipe. So it will update the symbol appropriately. So if I go to the 3D view now, you see that this pipe is risen above it by what? 600 elevation.
100.
Yes, madam.
Okay. Sure,
The
thank
same
you.
principle is applicable to pipes, ducts, conduits, and cable trays. They all behave the same way.
Okay.
Yes, madam. Any question? Nico? Fire.
Yeah, I'm fine.
Are you okay?
I'm okay. I'm okay. I have no question.
Okay, fire. Mr. Dixon. Dixon. Ima. Mr. Jerry Atipo.
Yes, sir, I'm here, sir.
Are you okay?
Yeah.
You're okay.
Yes, please.
Okay, thank you. So that's how we draw these basic things here. They are linear objects. You must know at any point in time, whichever pipe you are drawing, the elevation you are drawing the pipe. So let me consider structures also. Let's go to structure and take something like a beam. As soon as I click on a beam is also an horizontal object. So any beam you are drawing, you must also know the level on which the beam is going to what? Be. You understand? So as soon as I click on the beam, you see that the work plane is here on the constraints, and it's telling you that the level is what? Foundation level. So anytime I draw the beam, it will be drawn on the what? Foundation level. If I change it to first floor, it means that whatever beam I am going to draw will also be on the what? First floor level. So if I click here and then draw this beam, what it means is that this beam that I have drawn is on the what? First floor level. So if I go to the elevation south and I look at it, I'll see my beam here. And you see that this is the beam, and the beam is associated with the what? First floor level. And with the beam, you can specify the start level offset and then the end level what? Offset. So if I change the start level offset to say 600, which means that the beam will be above the level by what? 600. Then the end level the end level offset to, I can make it negative 600. So it will come down by negative 600. If I want it to go up, I can make it positive 600. Then the beam will be positive 600. If I want to change the reference level, I can change it to ground floor level. And if I change the ground floor level, then I'll have to update the constraints, the start level offset to 0, the end level offset to 0. Then the beam will be on that level. Then you have a beam drawn. And when you are creating a project, if you can draw and position a single beam, you are good to go. You don't need to assume 1,000 beams at a time as a beginner. Learn how to draw one beam and then operate it and manipulate it and understand it. If you can draw one beam, then you can add 2 beams, you can add 3 beams, then you can add 4 beams. And it's just a linear element here, as you can see. Any question? Any question? So a wall is a linear element. You have to specify the base constraint and then the top constraint. Cable trays, conduits, pipes, and ducts are all linear elements. You can draw them and associate them with a level. But there's one thing about what do I call it? One thing about system objects, that is the ducts, the pipes, and then the cable trays. There's something called fittings routing. You look at the fittings routing later on. If you don't do the routing settings correct, anytime you try to draw these pipes, you get issues. But for now, as for today, I won't go there so that it will not distract us. But I'm assuming that the fittings are already properly installed, so that when you are drawing them with the proper fittings, you can easily draw them. Because for instance, if I take this pipe here, it's 150 mm. If I try to create similar, and then I change the size of 150 mm to say 50 mm, and then I continue this pipe from here to here, Revit will automatically add a reducer for me. as you can see, it automatically add the reducer for me to be able to draw my pipe. And we will look at all these fitting settings later on. If I want to add a bend, create similar, and I click here, Revit automatically add what? A bend for me. And if you have a bend like this, if you select this fitting, you see that there's some plus and minus sign here. If you click on this plus sign, it will add another bend to the right. If I click on this one, then click this minus sign, it will remove the bend. If I want to extend it here, I'll add a plus sign here. Then to extend it here, so I can select this one here, right click here, draw pipe. Then I can also draw another pipe from here and then continue from there. It's something basic. You need to practice to get comfortable with them. Any question? All these elements that we've discussed here, they are linear elements. They have lengths. So if you draw a wall, it has a length. If you draw a pipe, it has a length. If you draw a cable tray, it has a length. If you draw a beam, it also has a length. They are all linear elements. And you can edit the length of each of them by clicking on the length and updating it appropriately. So when I change the length of this one to 2002, the length will automatically what? Update. So they are linear line elements. Start point, end point. And if it's a wall, you have to check the base constraint, you have to check the top constraints. If it's a pipe, a duct, a beam, a cable tray, you need to confirm the level on which it is, and then the elevation the object is in relation to the level to which it is what associated with. Any question? Any question? Oh, we are all good.
Yes,
Yes, sir.
You are good.
I think you are good.
You are good. Okay. Now let's look at another set of objects. These objects, for them, they are no linear elements, but they are point elements. You don't draw them as a line. They come as points. You place them at just a specific location. So if you take something like a column structure, then go to a column. If it's a column and it's a vertical column, as soon as you click it, you have a column there. Okay? You don't draw it as a line. It's just a point that you place. So for instance, if I go to the ground floor, then I come in here, then I pick a column. As soon as I come in here, I must specify that I have the height here of the column. Then I click here. As soon as I click, I place it at one point. And when I select this column, I must know the base level that the column is starting from. In this case, ground floor level. And then the top level that the column will be what? Extended to. In this case, the first floor level. So if I go to 3D view, I see that I have two columns here. This column here starts from the ground floor and it ends on the what? First floor. This column here starts from the ground level and ends on the what? Ground floor. I can decide that this column should terminate on the what? Roof level. Then the column will be terminated on the what? Roof level. So that's a linear element. There are some elements which are just point reference. So this column is a point reference. But only that you must specify the point you want to place it, the base constraint, and then the top constraint. But if you take something like a furniture, if I go to architecture, and I go to a component here, and I go to place component, and I pick, say, for instance, a WC. This WC is not a linear element, it's a point reference. Point reference. So I need to just pick one point and then place it. As soon as I place it once. It doesn't have any length. So when I select it, I can only change the level on which what it is. So I can put it on the foundation level, I can put it on the ground floor level, I can put it on the what? First floor what? Level. So I have to go all the way up. So those are point reference elements. So if you are dealing with any object, you must know this object that I'm working with, is it a point reference? If it's a point reference, does it have a base reference? Does it have a top reference? Does it have just a level? If it's a linear object, does it have a starting point, then the end point? If you take a pipe, for instance, you just need to know the level on which it is and know the offset from the level. If you take a wall, for instance, you must know the level on which it is starting, then the level on which it is what? Terminating. Are you okay? Are you okay?
Yes, please.
Okay. Now, there's another set of elements. They are not point reference. They are not linear. But they define a region, a space, region. So you have to draw a rectangular shape, a shape to define them. For instance, floor. If you take a floor, architectural floor, with the architectural floor, you need to draw a polygon, a closed polygon. When you draw a closed polygon, you need more than 3 lines. Let's say 4 lines here. I can remove 1 line here and I still make it 3 lines. So I form a closed region. So it might define a region that will give you a floor. And when I finish this one too, it will define a floor for me. So this one is a floor. So when I take this floor, for instance, I can take it and when it is drawn, I can assign it to any level, ground floor, I can assign it to what? Foundation, I can assign it to what? First floor level. So for something like a floor, a ceiling, a roof, a beam system in structures, like say, let me go to structures here. Structure. Then go to beam system. If I go to beam system, then I can draw a beam system, let's say circular shape. When I draw the circular shape and then I finish it, it will create a beam system for me. Beam direction not specified. So I need to specify the beam direction. Continue. So the direction must start from, I want to draw a line. Let's say from end here to the end here. This should be the direction for my beam. When I finish, then to create a beam system for me like this one. So this is an object defined by a region, which is called beam system. And when I have these beams and I select it, I can specify the pattern. We call it the layout rule. Layout rule. So you can go say I want a fixed distance. So I want to say 600 spacing. If I do that, then to give me 600 spacing between the what? Beams. This beam member here, it can be any member. In this case, it's I section here. It can be a wooden member, it can be a steel member, it can be any member, any structural member that you can design. You can replace it in this beam system here. So that one, to define a region and then you put it there. If you want to do a roof, architecture roof, and go to by footprint, that one to you might define a region. And when you define a region, then you finish, it will also create a roof for you. So this is the caveat. The object that you are creating, you must know that this object that I'm creating, is it a point reference like a WC or a furniture? Is it a is it a linear object like a wall or pipes? Is it a 2-point reference like a column? Is it an area object? There's nothing more to it. Any other object that you create, it should belong to one of these groups. Either it is defined by a region, defined by a point, or defined by what? A line. Nothing more. Any question? Are we okay?
Yes, sir.
Is everybody okay?
Yes, sir.
Okay. So now I can delete everything here and I start working on something realistic. So I'll select everything, then delete. Then go to the ground floor. When I come to the ground floor, please, these elevation markers, they are not fixed. You can always move them around, okay? So depending upon the size of the project that you are working on, you can move them around and then model your structure for it to fit in between this one. So I can come here to ground floor and pick a wall. When I pick a wall, I'm drawing the height. You can draw the depth. If you choose depth, which is that the wall must go below. If you choose height, the wall should go what? Above. So I'll choose height. And I want it to be constrained to the first floor. Then I want to draw a rectangular wall. So when I come here, I can draw a rectangular wall like this one. So that's my wall. When I finish drawing, I can select the wall and update this distance to say 12,000. I can select this one, update this one to say 6,000. So this gives me 12 meters from here to here, 6 meters from here to here. Because when I select it, I see this value. When I select this one too, I see that value as a dimension. I can click this wall, create similar, and then add another wall in between this and this. Please, because you all have architectural or structural or mechanical or something background, with the basic understanding that we know now, you should be able to pick any wall and then lay out any building the way you want it. So mine is just a simple 2-room building here. If I want, and I want to partition this room further, I can come in here, create similar, and then start from here, draw another wall here, bring another wall here, then bring another wall here. And then I will decide whether this room is going to be a room or this is going to be a shower or it's going to be a closet or whatever. The discretion is based upon you. So please, I'm going to use a building that I'm going to use on to work. Tomorrow I'll make that building available to you in a card form so that you can draw over them. But I expect everybody also to pick a small project that you can work on, maximum 2 stories. Don't go beyond 2 stories, a small project. Then you've already finished with the design. And then begin to draw it out. And then we see how best we can draw it out and then get it completed. But in the same class, you work on my project. Then you too, you can also work on your project. Then if you have questions, then you can ask them. Okay. Now within this building, I've added 4 walls, some few walls here. I can then go in and pick a column structure. And when I pick a column structure, I must define that I want it a height, and I want the height to be on the first floor. So I can pick this corner, I'll put my column there, I'll put 1 column here, put 1 column here, put 1 column there, put 1 column here, put another column here, put another column there, and then put another column here. When I was drawing, I made a mistake and placed this column here and place that column here. I can select it, move it, and then position it well. I can select this one also, move it, and then position it properly. So I have my columns placed. So I have a column placed where I need them. Okay, maybe I don't need this one, I can delete. I don't need this one, I can delete. So I have 6 columns placed. I have some few walls placed. If I go to 3D, I see my walls and my columns drawn. For now, I'm not bothered about the kind of column I have placed. I'm not bothered about the type of the family of wall I'm drawing. The most important thing is that you should be able to create a wall. You should be able to create a column. At the right time, we will discuss what family of wall, what family of column, what type of wall, what type of column you are dealing with. If I am done, then I want to add, assuming that this place is a sanitary area, then I want to add some pipes in this room. Then I'll go into my system here. Then I'll go and pick, say, pipe. And then the pipe that I'll pick, I want it to be middle elevation of 0. I'm on the ground floor. If I start from the middle here, maybe it is a floor drain. I'll start from here, draw my pipe to the outside, and then go here. I'll come in here, draw another pipe also from the middle here, come in here, and then draw it. When I finish, I want to connect this pipe to that pipe. So I'll select this bend here, add the plus sign. It will add the bend automatically. Right click here on this knob, draw pipe. Then I can draw pipe from here to come and join this pipe. Then to add the bend automatically. So when I go to 3D here, you should see my pipes drawn at the back. As you can see, these pipes, if I select them, I know the elevation that they are and I can draw them. Any question?
So we are okay.
You are okay.
Yes.
Anybody has a question? Antoinette, speak for yourself. Or don't say we are okay. Say I'm okay.
So I'm okay.
Gary.
Okay.
Yes, sir.
Right.
I'm here, I'm fine.
You are fine.
Yeah.
You are good.
Yes.
Okay. Any question again? Now, if there are no questions, then let me add another datum element to finish the datum issue. Then if you go to the architecture and go to datum, you see that there's also a grade. Apart from the level, there's a grade. Let's look at how you can work a grade also. Okay? So I'll go to the ground floor. To create a grade, you can only create a grade in the plan view. You cannot do it in a 3D view. You can do it in a plan view on, I think, elevation and section view. But ideally, it's better to draw your grade in plan view. So when you are in a plan view, you can choose a grade. Then you can click anywhere and then draw your grade. Just like the level, the grid also comes with a symbol at both ends. So you can check it here, then you can also uncheck it here. Are you okay? So if you want it on both sides, then you check both sides. This green line, we can customize it to meet your standards or your office standards. This grid here too, you can customize it to meet your standard. By the time we finish with the training, everybody must be in a position to customize this grid head in such a way that it meets your office standards, so that when you print it out, it comes out the way you want it to be. But for now, just know how you want to create it. When you finish it, as soon as you create a first grade, it will give you a number 1. If I copy this grade to the left, it will continue the numbering for me, number 2 for me. If I copy it again, CO, it will give number 3. As soon as I edit the number 3 to say number 6, Revit will remember the last value that I entered. So if I copy it again, it will continue from number 6 to number what? Number 7. That's how it behaves. If I want to do the horizontal grid member, I'll right click, create similar, then draw a horizontal grid this way. As soon as I draw it, then I will rename this one to say grade what? Capital A. So as soon as I create similar or copy it, CO, copy it here, then this one will be grade what? Grade B. If I create more grades, or I'll go to architecture again and then choose grade, then I draw another one, it will be what? Grade C. It's horizontal. If I want to go and continue the vertical here, because this is grade C that I did the last time, if I come here and then draw another one here, it will continue at what? Grade D. Then I need to come back and edit it to say 8 before I can continue. So you must know the numbering convention that you want to use. The grade always remembers the last value that you entered. So if you continue from there, the numbering will continue from that point there. So basically that's how we draw grades. If you go to the elevations, you see the grades there.
Recording in progress.
If you go to the elevations here, say south here, you should see the grades that you've drawn.
Okay, please, you can't see your interface.
It's gone again. I think there was an internet distraction.
Yes.
Okay. This Zoom, this internet Ghana, wahala. You cannot see it. It's back.
Yeah.
Uh-huh.
Yeah. Yeah.
So
Yeah,
if you come to this grid here also, you see it is in elevation. You can still copy it from here. If you copy it from the elevation here also, CO, it will continue from the last number to number what? Number 9. If you change the number here to say 2A and go to the plan, it will be updated on what? On plan. So you can see it here as 2A. Now, one thing that you should take note of is that when there is an intersection between two grids, where the point of intersection is, and I place a structural column there, a structural column, vertical, and I put it at the point of intersection, you see that the two of them are highlighted. When I click, Revit intelligently knows that this grid and this grid control this column. So that when I move this grid to the left, it will move with the column. When I move it to the bottom, it will move with the column. When I move it up, it will move with the column. Now, when you select the column and then go to the properties, you will see that there is a column location mark telling that it is C1. So that it knows that it is on grid number C and then grid number what? 1 in terms of what? Location. If I draw a beam also can be constrained to a what? A grid. So this beam will also be constrained to the grid. So when the grid moves, the beam will also what? Move with it. That's the basic thing about grid. It helps in constraining structural elements. Are you okay? Are we? Any question? Hello? Kafui? Hello, Kafui? I can't hear you. Mr. Benjamin? Ben?
Yes.
Yes, Kafui, are you okay?
Yes, please.
Dixon?
Yes,
Mr. Dixon? Are you okay?
Yeah, I'm here.
You are good.
Yeah.
Mr. Ima? Ima, unmute your camera and talk. Are you okay?
Mankind, all is well. You can proceed. Thank you.
Thank you, boss. Okay. So now, with this understanding, this is just the basics of it. For you to understand this one, being able to draw these things are basic. So architecturally, there are some elements that we call system elements that you should know how to work with them. How to work with walls, which we discussed. We've also discussed how to work with floors and then roof. Stairs is another thing. We look at stairs tomorrow. Stairs and railings, we look at them tomorrow. So those things, you should be able to draw them and then put them together. Now, there's one more thing that I want to ask to discuss. Rooms. As soon as you create a space, 1, 2, 3, we have 1, 2, 3, 4 space here. You can add a room to define the space. So you go to architecture, then you go to room here. You can pick a room here. So when you go to drop down, then you pick room. Anytime you see a space bounded by a walls, then you can define a room. You can decide to target on placement or on target on placement. By target on placement, then there will be a room here. I can put another room here. I can put another room here. I can put another room here. Please, the rooms also, if you select any room and then go to the properties, you must look out for the level on which the room is. Then the upper limit for the room. Then the limit offset. So currently, the upper limit for the room cannot be ground floor because the room is starting on the level ground floor. So the upper limit should be the level above it. Let's say first floor. And then the limit offset should be what? 0. So if you look at it this way, this room now here is on the first floor, starting from the ground floor and then ending on the what? First floor. Meanwhile, if I select this room here, it is starting on the ground floor, ending on the ground floor with a limit offset of 0. Let me take a section to explain what I'm saying. So I'll take a section through the building from here to here. So there's a section here. Now when I open this section and select the room here, you see that this room starts from here to there. And if you start to say it's starting from the ground floor to here, you see that it doesn't touch the top level here. There's a small gap between here and here because it's about 3,048. Meanwhile, the floor to floor height is at 3,150. So there's a gap here. But if I select this room here, you see that it flashes with the what? With the first floor exactly. I can give it a limit offset. If I give it negative 600, then it means that the room will drop negative 600 relative to the level. If I give it positive 600, then it means that the room will go above the level by what? 600. So depending upon the space design, whether you're having a drop ceiling or whether you're having some whatever, you can always constrain the top and then the base of the room. So for now, let me put it just on the what? On the level and say 0 here. That is for the room here. As you have it. Now, all the things we've created, being it walls, floors, all the 3D objects, you can create a schedule for each of them. All of them. So I can know how many pipes I've added in my drawing, how many pipe fittings I've added in my drawings, how many walls I've added, how many columns I've added, how many beams I've added. I can do a schedule for them. So let me do for pipes, for instance. So I'll go to view menu here. Then go to schedules here. I'm starting schedules early so that you get used to early because you'll be using it a lot of most of the time. So I'll go to quantity and schedules. If I go to quantity and schedules, I can filter architectural element, structural element, mechanical, electrical, piping, and infrastructure. Let me do architectural, let me do multiple. If I do multiple, I can see all the things that I can schedule, everything that I can schedule. And they have been arranged in alphabetical order, but I want to schedule pipes. So as soon as I select pipes, so that to tell me that I want to create a pipe schedule, then I go to OK. If I create a pipe schedule, I'll see all the available fields associated with a pipe, which I can add to my schedule. The list you see here, I call them the default parameters. By the time we finish with this essential training after the 25th meeting, you should be very, very comfortable with all these default parameters. Before you make an attempt to come and study the mastery level of Revit, then it means that you realize the limitations in some of these things. That is when you need to do the mastery level. But if you still have challenges with some of these things, then the mastery level will not be suitable for you to pursue. Okay? So for the pipe, I want to know the level on which the pipe is, so I'll look for level. It's alphabetical order. Look for, is there a level? Let me add, is there a level? There's no level. Let me look for, okay, additional flow, I'm coming. Assembly, comments, correction type, cost count, critical path, description, diameter, exchange, exports, family type. Okay, let me bring the family first. Family of the pipe. Then let me bring in the type of pipe it is. I want to know the length of the pipe. I'll bring it in here. Then I want to know the constraints. Upper end, bottom elevation. Upper end. I want the middle elevation. M. Okay, let me say I choose maybe upper velocity pressure. Let me pick. You can pick any lower center line elevation. Then I'll add it. As soon as I go to OK, it will create a schedule for me, and I'll know the pipe I'm working with. Pipe types, family. Now know the type of pipe. It's a standard pipe. The length of the pipes are all here. Then the lower end elevation for the pipes are all here, which I can see. If I want to add more schedule, I can go to the fields, edit fields, and then I can add the fields that I want to add to the description for the pipe. I can add the flow for the pipe if I'm interested in that. If I want to know the mark for the pipe, I can add it. If I want to know the manufacturer for the pipe, I can add it. If I want to know the outside diameter of the pipe, I can add it. As soon as I add them, then all those parameters will be added to what? To the pipe. So this one will give me a pipe schedule. And if I go to my schedules here, I'll see that there's a schedule here showing me my pipe. If I open the schedules here, working schedules here, you should see all the pipes that I've created, including my pipe what? My pipe schedules here. Okay. If you go to the schedule, it says by type, but I want all. By browser properties, I want all the pipes. So I'll see all the pipes. So this is my pipe schedule. There's a level schedule defined. There's a door schedule here. If you go there, it is empty. They've defined the mark, the width, the height, the thickness, the material, the finish, undercut, material type, finish, head, jam. But because there's no door, it's still not there. But as soon as I go into the project and I add the door, it will be updated. If I want to do a wall schedule, I can go again to view schedules and quantities again, then look for wall all the way down and look for walls and click OK. Now to create a wall schedule for me, for the wall, I want to know the level on which the wall is. It's not giving me the level, but I think it should give me the base constraint. The base constraint is here. It should give me the top constraint of the wall. Top constraint is also here. I want to know the length of the wall is here. I want to know the type mark for the wall. I'll add it. I want to know the width of the wall. I'll add it. I want to know the area for the wall. I'll add it. I want to know the volume for the wall. I'll add it. If I go to OK, then to give me my wall schedule. So I know the walls, the base constraint for each wall, the top constraint for each wall, the length for each wall, the type mark, the width for each wall, the area for each wall, and then the volume for each wall. If I go again, I have a beam here. This is the MC shape, structural framing. So if I want to do a schedule for structural framing, I'll go here. There's a structural framing schedule. If I open it, you see that there's only one component here, which I have added. So you can see the wall, the structural members. If I want to format the fields, I can open it, then add more fields to it. I can add keynotes, I can add a model, I can add type mark. These things, you need to play with them. And if you have a challenges, you can bring it up, then we can what? Address them. Any question?
Mangai,
Yes, sir.
please can you hear me?
Yes, I can hear you.
When it comes to the scheduling and what you were doing, you were a little bit fast. I don't know if you can take your.
Okay. What I'm saying is that any 3D object, architectural, structural, mechanical, electrical, you can schedule it. So if you want to schedule it, you go to the view menu. Then when you go to the view menu,
Okay.
you go to create. Then under create, you look for schedules. So if you go to a schedule drop down, you can go to schedule quantities. Then click on that one. It will open this dialog box for you. You will see all the elements that are within your model. It can be multiple. You can sort them. You can uncheck structure, uncheck mechanical, uncheck electrical, uncheck piping, and then only check architecture. So if you check only architecture, you see only the architectural list that is here. Okay. So if architecture, I want to do, let's say, a wall schedule, I can do that. If I want to do a room schedule, then I'll go and look for room. Okay. So this will give me the rooms.
Yes, sir.
So you select the room and then click on room word. You see that it will automatically name it as room word schedule. You can rename it the way you want to name them, but for now let me leave it at the room word, room schedule. As soon as you do that, then go to what? Okay. Then this one will bring another dialog box called schedule properties. So you will decide that the room schedules that you want to do, what properties of the room do you want to include in the what? In the schedule. So you get the available fields on the left. Then there's the one that you want to appear on your schedules, you shift them to the right here. So for the room, for instance, I want to know the level on which the room is. I'll add that one. I want to know the name of the room. I'll add that one. I want to know the number of the room. I'll add that one. I want to know the area for the room. Then I'll add that one. If I am interested in the perimeter of the room too, I can add. If I want to know the volume for the room too, I can what? Add. So when you select the things you want to include in the room and you are done, then you click on what? Okay. As soon as you do that, Revit will identify all the rooms that you have created in your project and tell you the level on which each room is, the name of the room number, the area of the room, the perimeter, and then the what? The volume in the room. If I want to include more things, I can do that. Are you okay?
Thank you. Yeah,
So for instance, if I go to ground floor level and I go to massing and sites and I go to plant components and I pick plant 1, plant 2, plant 3, plant 4, then I go and change the plant type and then choose a different plant. Let's say this one, then another plant. You see that I've placed how many plants? 6 plants.
6.
Yes.
Yeah.
So I can do a schedule for these plants. So I'll go to my view menu, go to schedules and quantities, and then look for what? What should I look for? What should I look for? Plant. So I'll scroll down, it's alphabetical order. Look for plants. So this is it. Planting here. You understand?
Yeah.
So I'll get planting schedule, then I'll go to OK. Then I'll choose for the plant, what information about the plant am I interested in? You understand? I want to know the level on which the plant is. I want to know the family of the plant. I want to know the type of what? Plant. I want to know the description of the plant. I want to know the count of plants. Okay, then I go to okay. So Revit will generate all the plants for me. So you see that I see 1, 2, 3, 4, 5, 6 plants. It's not been formatted. There are tools that you can use to format the plants. You can sort them, you can group them. So if I go to, for instance, edit, I want you to sort the plant by level. After that, I want you to sort the plant by family. And when I sort them to, I don't want to itemize every instance. Then I go to OK. So you see that there are how many plants? 6 plants, all in all. You understand? If I go to formatting, then I say I want to sort by the type of plant here. Then I want a header for the type. I want a header for the family. Then I go to OK. Revit will sort them that this Horton 7.4 meters, there are 2 of them. This particular one, there are how many of them? There are 4 of them. So you can manage them and then group and sort things in an orderly manner. That is what we use the schedule to do. There are some things that you, if you look at the floor plan or sections or elevations, you might not see them. You might not see those things. But as soon as you create a schedule, the schedule will let you know what is going wrong somewhere. It's a very analytical tool that we use in modeling, so you'll be using it most of the time. Are you okay? Normally, we use schedules in conjunction with a legend. So if you come to here, legends here, I can come to legends and then create a legend. So I can right click and choose new legend, or I can go to view menu here. Then when I come to view, I go to legends and I can choose a legend. Then I can create a new legend, then I call it a planting legend. Plant legend. Plants. I'll call the legends plant P. Then go to OK. So as soon as I create the legend and I go to annotate, then we have a component. Then we have what you call legend component. So if I come to legend component, all the 3D objects, 2D objects that I'm working with, you see them here in a long list. Everything. So I'll scroll to the level where I have my what? Planting. So if I come to the plant, you see all the plants that I'm using are here. So I'll select this plant, then I can put it in a legend. I can select another plant here. I can also put it in a legend. I can select another plant here. I can also put it in a what? Legend. So they're all different plants. When I select this plant, I can copy it to the side. It's the same plant. And when I select the same plant here, for now, I'm looking at this plant on plan. If you look at the direction here, it says that it's a floor plan. I can look at it in elevation font. So to give me the elevation of the plant, I can select it and look at it from the right. Any view that you want to look at it, you can do that. And for any 3D component, you can do a legend for them. So I can copy this plant also, copy it, and then bring it to the side. Then I can also look at this plant that I've selected here, look at it in elevation front. They say, oh, this is not a plant. This is a, what is it? It's a plumbing what? Plumbing fixture, and it is a what? A floor drain. So this is a floor drain in plant. This is a floor drain. So any object that you see in your model, you can do a legend for it and then populate it on your sheet. Are you okay?
Yes, sir.
Yes.
I think this is a good point to stop. Tomorrow, when we meet, we are meeting tomorrow. When we meet tomorrow, we will take a typical project, the one that I gave it to you. Then you try and then model it out. Draw the walls out. You understand? And then work on a real project. Add the floors, add the ceilings, add those things. Any question? Please, can we add Tuesday to the meeting? So that we finish early. So you can meet Monday to Thursday. Or Monday, Wednesday, Thursday is okay. Monday, Wednesday, Thursday. Or we can meet from Monday, Tuesday, Wednesday, and Thursday. So
What about Saturday evening?
He said,
Saturday evening.
Saturday, there are senior men amongst us, so most of the time Saturdays we go for weddings and funerals and all those sorts of things. Most of us will get home and we can be very tipsy. He said,
We will also go for church on Sundays.
You also go for
So
church
it
on
will
Sundays.
be a bit inconvenient.
It will be inconvenience, yes.
Please, let's leave the weekends out.
Let's leave the weekends out. So
Yes,
if you
please.
can meet Monday to Thursday, it won't be bad. Fridays to me, every Friday they are doing sitting, so Friday there is out. So I suggest if you can add a Tuesday to so that you can meet 4 times in a week, then you can finish earlier. Instead of us going for about 9 weeks, in about 7 or 6 weeks you can be done. The earlier you finish, the better. Maybe you can discuss it on the platform, maybe tomorrow onwards, okay? Maybe we are meeting tomorrow.
Okay.
So tomorrow we will take a typical project and then we will work on that typical project and try to achieve a result. We will work on the levels again. We will start all afresh. Create levels, create grades, add walls, add columns. Whatever we can add till we finish, we will do that tomorrow. So we work on the project that we discussed. This particular project, let me show you. This one. We work on this project tomorrow. So I'll send you the CAL files before we start the class, okay? So you guys can use it as a reference. Okay? Yes. Is somebody speaking? So these are floor plans. These are the columns. So we are going to size the columns, we are going to size the walls, and then draw them. Okay? Then you add the plumbing fixtures, anything that you can add to improve on the project, we move on from there. Any question, any suggestion? If no question, if no suggestion, I suggest we close for the day. Hello?
Yes, sir. Thank you.
Yeah, okay.
Yes, sir.
Yeah.
Gary,
It's fine.
you are cool.
Yeah, it's fine.
Okay. So tomorrow, all the things that we discussed today, tomorrow we will try our best and then implement it on this particular project. If you two, after the class, then you two can go and try it on your personal project.
Okay.
So that if you have any personal issues, you can let us discuss it at our next meeting.
All right.
Thank you very much for coming.
You're welcome.
Thank you. Please, I will save the video and upload it to my YouTube channel so that if you want time to watch it over, then you can go and watch it over there.
All right.
Thank you, sir. Thank you, madams.
Recording stopped.